All right, in this video, I will go over a few problems or things that you might run into when using the robots plugin with Universal Robots or any kind of 6-axis industrial robot. And I can hopefully show you why these errors or warnings happen and what you can do to solve them. A quick refresher. We have the create program component, and this creates the code, the actual code that is then sent to the robot. It also creates warnings, and it might create errors if there are any. The warnings will not stop us from sending any program to the robot. However, the errors will actually block us from sending anything to the robot, even though it might look as though some of the targets are actually valid and maybe parts of the program are in order. We can still not send it if there are any major errors. So let's look at the warnings that I get for this robot program. In this case, it's this program where the robot follows this curve and also follows the curvature of the curve. The first error that we get is the first target in robot 0 changed to a joint motion using axis rotation. If we look into the target creation, we can see that our motion type is set to linear. That means that all of our points, the motion between each point is actually a straight line. However, this tells us that this first target is actually changed to a joint motion instead of a linear motion. And we can also see this in the robot code. We can see that this first command, this first motion command, is a move J command instead of a move L. What this does is simply set this first target not with the coordinates in space, so we're not giving the robot the coordinates, but instead we're actually giving the robot the rotations of each axis, and this makes sure that the robot always starts in the same configuration. Otherwise, if we would not do this, we would actually send the robot the coordinates, and the robot will decide in itself how it actually configures itself to reach these coordinates, and it might do so in different ways each time depending on the position that it's in. And so this basically gives us a lot of security, or basically assures us that the robot always starts in the same configuration. The next next warning, that we get is 19 targets have their speed set to default, the first one being target 0 in robot 0. This is just kind of a notice to us that we don't have a speed set, and that it will just be the default speed of the robot, and that it's probably advisable that we actually set the robot speed ourselves. The next warning is 18 targets are set to linear with a forced configuration. Configuration setting is ignored for linear motions. What this means is that in our create target, you have seen that we can change the configuration. So we can change the way the robot is configured when accessing a certain target plane. And you can see that the actual tool is always in the same position. The actual way the robot gets to this target doesn't change. However, the configuration of the robot changes. This can only be done if we're actually not using the coordinates as we do with linear motions, but instead we use joint motions. And this basically tells us, hey, you might have set the configuration here, but it's not guaranteed that the robot will actually do it in this way, since it's a linear motion where the configuration cannot be guaranteed. The next error is a speed limit. The next warning is a speed limit warning, which basically tells us, hey, at some point there is a lot of motion or a lot of movement that is needing to be performed by axis 6. So in this case, it's the last axis of the robot, and the robot will actually slow down because it cannot. This last axis has to do such a big motion in a certain distance that it will actually slow down because it can't keep up that fast. As I said, all of these warnings don't stop us from actually sending this program to the robot, but they're always important to look at. So for example, if you have a process that has some sort of extrusion, a speed limit will actually tell us, hey, I will move slower than you might expect at this point. And so this will then tell us, hey, if we have an extrusion process that continually extrudes something, we might have excess material in this or at target 11 in this case. And with the other things, the other warnings are also important, because we might recognize, oh, we might have forgot to set a default speed, or we might have set a configuration that was very important, but in by the way our targets are defined as linear targets, we can actually not guarantee these configurations. Now, if we have more serious problems, we will get errors. This is, of course, probably one of the most obvious ones: target out of reach. So yeah, the robot simply can't get to this target because it is out of reach of the robot. And you can see the robot is fully extended, but it could not reach this curve the way it's supposed to. This is also something that sometimes happens without it being obvious why it happens. For example, it could be the case that the robot is set up to access a plane from a position that we that we did not expect. So for example, we thought that it might access a plane from the top, but it's actually accessing it from the bottom, and so the robot actually has to extend itself in a way we didn't expect, and that will then cause the target to be out of reach, even though if the robot might be configured differently, then it might not be out of reach, and it might be perfectly in the robot's reach. So the configuration and the orientation of the TCP are important for whether or not we can actually reach a target. There are many other errors that can happen. For example, let me add these multiple circles, and if we set multiple curves here, and we will also flip this plane so that we access it from above, we will get an error that is axis 6 is outside of the permitted range. And this happens because right now we have still set our program or the TCP to follow the curvature of each circle. And I hope you can see this. If we go through here, you can see that the tool rotates along the path of the circle. However, our robot cannot rotate indefinitely. Some robots can do this. For example, universal robots UR3s can actually rotate indefinitely, but other universal robots cannot. And so if we actually follow this and always rotate, at some point we will get into the axis limits, and we cannot rotate any further, and we cannot simply go to the next point, and the robot is not smart enough to basically stop, unwind itself, and then go back down. So in this case, our axis outside of the permitted range, and this happens often if we have circular or closed curves that we are following with a horizontal frame, or following and also following the curvature. And this is something where we then would manually have to implement basically a reset point where the robot actually stops following the curves, goes to a neutral position, can unwind its axis, and then go to the next circle and have another 360 degrees it can rotate before getting into the next limit. All right, there are many other errors that you can run into. I will not go over all of them. You will probably run into more errors than you would like to over the course of using the tool. If there is something that you can't figure out, you can always also ask in the robots discussion forum on GitHub. So this is github.com/visose/robots/discussions, and there you can also ask questions and hopefully get help for any problems with the robots plugin that you might run into, and also problems that might come from the interaction between the robots plugin and the actual robot that you're using. If you have any questions, you can leave them either in the comments or you can contact me in other ways. All right, that's it for this video.